All right, so today we should really get started with the OOP review. I plan to spend today, Thursday, and next Tuesday finishing up the materials I would like to cover just to remind you about what you're supposed to learn from the first year. And as I said, the first 2 weeks will be the best opportunity for you to catch up with any basics you may not have learned properly, maybe from the first year. The first 2 weeks, please spend extra time if needed for yourself. And there will be quite a good part of the slides for this particular review slide. These self-contained. I may not go over like a read them off every time. It may not be worth your time. What I do instead is I'm going to go over some example with you on the iPad. And for today, maybe in the final bit, I will start doing some code demo together with you. I'm going to develop some example which you didn't see in the Lab 0 Part 1. That could be a nice addition. So instead of going through the slides, I'm going to assign them to you for reading, and I'm going to illustrate all the concept over there in the code demo, which I'm going to do today and also Thursday. All right, we'll see how that goes. And I would like to start just by having some, that's what I usually like to start with, some announcement or reminder, just to see where we are. So number one, your priority now should be to go over Lab 0 Part 1 to complete it. Remember, not just the tutorial videos you want to study, but also there are PDFs. If you have no idea what I'm talking about, please refer to the instruction. All right? And for your Lab 0 Part 2, I'm just doing the final edits. It will be ready later today. But the due dates for Lab 0 Part 2 is next Friday. Not this one, but next one. I'm releasing it. So for those of you who want to stay a little bit ahead of the class, feel free. Okay? So for tomorrow, of course, you can also ask questions related to Part 2. I will be there tomorrow for the lab session, the morning, the afternoon, both. And what I plan to do tomorrow, maybe to encourage you to come over. I'm going to do some in-lab code demo, possibly not 3 times, among the 3 rooms, but maybe I'll try to do in a single room, I will gather everybody. And then there is one part of the review slides over there, which I'll show to you. It's something about helper methods. So the idea about helper methods is not really OO. It exists way before OO was invented. It's really about improving the structure and code, like a structural efficiency of your code. So it's a very nice thing to really also incorporate in the review lecture, so you can also start applying them in your lab exercises later. And I do have the slides already on the helper methods. So what I will do tomorrow is I'm going to show you how helper method can be understood on Eclipse. I think that'll be a nicer way to learn, just to reinforce. Okay? So I do encourage you to come tomorrow. And then I might do some other SWOT demos as well in the lab. So come, and then either in the afternoon or the morning, I will do the same demo. So guys, any question in general about the course you would like to ask me before I start covering review? Anybody? Everybody happy? I hope. Good. All right, let's now go over the slides. Well, you already got the PDFs. It has not been changed really from last time. So let's go from the beginning until the end. Set. A good part of it is assigned to you for self-study. They are self-study. However, if you find any parts you don't really or you need more information, drop by my office hour or see me in the scheduled lab or appointments. More than happy to help. All right, just a reminder, so the refurbished store is really what you're supposed to go over for Lab 0 Part 1. This one is required for Part 1 and Part 2. I'm going to refer to later. And so this one here is optional. Since we're using Eclipse, I would like to emphasize Eclipse is so-called an IDE, Integrated Development Environments. So it's an IDE for developing your Java code. Eclipse is not just one of them. IntelliJ could be another one or other IDE. And a particular concept I would like to emphasize is about using debugger. For those of you who are walking through Lab 0 Part 1, you have already seen some idea there. But I would suggest if you're still not very comfortable about using debugger and breakpoint in Eclipse, you can also refer to this optional tutorial as well. Or if you want to ask me about it in person, see me in person. And also other good stuff over there. And then These are the two PDFs you're required to go over for your Lab 0 before it's completed. The first document there is about how you can infer Java code, classes, methods from given JUnit test cases. It's going to be the format for Lab 1 to Lab 5 and also all your programming tests. So it's really important for you to understand completely what this document is trying to convey. I also make the source code that's mentioned in the documents available already. So please give it a try. If you got any confusion, you really want to ask me sooner rather than later. The second document there is about reference type attributes, especially how you can have an array of reference type attributes. So this is also something we're going to also talk in detail in part 2 of your Lab 0 tutorial. But I think this way it's more like to supplement, the visual experience. So this one is more like a written version of your Lab 0 part 2. I would suggest you also go over them thoroughly. I also got lots of good diagrams there to illustrate the concept, right? We might touch upon maybe a little bit next, either this coming Thursday or next Tuesday, a little bit. But I'm going to assume you're going to go over and come to me for questions. Right? These two PDFs are required. They are not optional. Okay, learning outcomes for today. For this lecture here, we're going to spend today, Thursday, next Tuesday to finish this, I'm hoping. We're going to review object orientation. So here, it's not even about object-oriented programming. I'm talking about object orientation. And question?
Sorry, what the PDFs? Are they also on the lab package that you sent us?
Yes, the PDFs are, if you go to the study site, they are already sectioned there. You can easily find them. If you cannot find them, you may want to refresh your browser. They are there, yes. Everything is made available to you. All right, back to this object orientation. So that will be the first thing I would like to clarify for everybody or to review. What does it really mean to program in the object-oriented way versus non-OO? That's something I would like to clarify. So once you understand about object orientation, it doesn't matter which language you might be using for OOP. It could be Java, could be Python, could be C#, any language that supports OO. That's the first thing I'd like to do. And we're going to review about classes as templates and also objects as instances. Right? You may have heard about those analogies back in the first year, but I'm going to review them as well and give you some examples and give you some exercise as well to try. Simple ones. Yeah, things like attributes, constructors, and also accessor versus mutator, right? Or getters versus setters. And this keyword, you may have seen that back in first year, and we're going to review that as well. And the new keyword here, and also the dot notation, right? You might say object1 dot some method, right? The dot notation, and how you can call the method. And also reference aliasing. Aliasing is another very unique phenomenon for OOP. So you don't really see the idea about aliasing in procedural language like C. Even to be more precise, you can simulate it using pointers, but that's not what you would normally do. But specifically for OOP, you do have the phenomenon of aliasing. That's what I plan to do maybe in the later part on Thursday. I'll try to give you some exercise sheet beforehand so you can try to work out the problem. That was a past test question that I can give to you for exercise, okay? I'll reach out to you when it's ready. And we're going to talk about reference type attributes, especially either you have no array or you have an array. Basically, that's the notion. But once you follow through the required videos and also PDFs, from Lab 0, you should be quite comfortable about these ideas. All right? Let's see. And also non-static versus static. You may have seen the keyword static. It's a very good way for declaring some global variables among all the instances. That's something I'll talk about as a final part in the review. So most likely next Tuesday, you can look forward to it too. It's quite useful. And helper methods, as I said, I'm going to do that tomorrow in the lab session. All right, about separation of concern, I just want to refer you to this diagram over here, which I'm not going to say too much. It's for your information to go over. So separation of concern is a very good design practice. You don't really want to collapse everything into a single package or the default package. It's almost like a Superman package, which will do everything. No, you want to separate the different tasks into different packages, right? And so you can see here we got the model package. So this will be for the business logic of your developments. Anything that you want to program in order to solve a problem, they should go into model. And JUnit test cases, right, for unit testing, and also for printing out something to the console. Gradually, you should really try to be less and less dependent on console apps. You don't always just want to print out something to the console. For some quick test, maybe, but for automated testing, especially regression testing, which we'll talk about a little bit later this month. And you definitely need a JUnit test and also model. All right? Keep these sheets handy whenever you want to remind yourself about what should really go to which package. You can always refer to this sheet. On the slides, we basically talk about the same thing. We got model components, storing Java classes, right? Different example here. And also we got some tester, could be console tester, but you should really try to stay away from that. It's too manual. It's not automated. And also, JUnit test cases is more automated for regression testing. So in Java, so this is a very crucial point. We may define more than one classes. I'm not too sure how many in each of your individual labs back in 1021 or 1022. I'm not sure how many classes you will have to deal with. I guess maybe not that many, or even just a single class. In OOP, it's not uncommon, or it's very common to have multiple classes there which will interact with each other. That's something I would like to give you a feel, maybe for subsequent labs, from lab number 1 to lab number 5. Very often you will have to program maybe 2 to 3 classes, and somehow within one class, you have to invoke methods from another class, and vice versa. Okay? It's a very common way of doing things. And just as a look ahead, when you get to the third year, 3311, software design, or 4315, software engineering requirements, you're actually going to deal with many more classes. Don't be too surprised if you have to create close to 100 classes, which somehow have to be related to each other. It's just common. Okay? But for this course, don't worry. Only a handful, just to be manageable. You're still learning. Yeah, in the classes, we got methods, we got objects, right? I'm gonna show you the difference very soon. And then, so at the runtime, the way you simulate what's really happening, the way you simulate what's really happening in the reality is by creating objects, calling different methods, and try to see what the return value are from the corresponding objects, basically. All right, so that's an overview. And then, right, so let's now clarify the philosophy or paradigm of object orientation. The way I put it would be there are 3 phases. We start with observing what's really happening around you that you might be interested in solving using. Model is based on your observation from phase number 1. You're going to translate or transform your observation into something that's syntactically valid. For example, if you want to use Java, you have to translate everything you observe into Java. If you want to express your solution using Python, you got to translate everything you observe into Python. That's what I meant by model. That's why we also got a model package, right? And the final stage is about execute. Execute is, based on what you have already modeled in Java, in this case, you're going to see how the different objects can be interacting with each other. And tracing the code is also a very important part for this course, which I'm going to demonstrate throughout the course. So these are the 3 phases. For now, you want to understand one thing here. Observe is only, let me put it this way. Observe is kind of beyond the scope of this course. Because in this course, you're always being told, at least indirectly, about what classes and what methods you're supposed to create based on the JUnit test cases given to you, right? That's why you need a PDF number 1. In 3311, software design, or in the requirements engineering courses, observe is a big part. that you have to figure out exactly what classes and attributes or methods you will need. But I'm just going to give you a few about how you make that, just some example, so it's complete. We're going to focus much more on model and execute, right? Let me show you one diagram here. I'm going to zoom in a moment. How about I do it now? All right. So there are 3 stages over here. Stage number 1, this is for observing. Stage number 1. Based on your observation, we're going to model in some particular programming language. And we call this compile time versus the final stage, runtime. Let's now clarify what these really mean. So compile time over here really means this is the timing where you're developing your Java code in the editor. So you're still developing your code in the editor. That's compile time, right? Of course, you might run into some errors, in which case you cannot really get to the execute phase. The next phase will be runtime. So here, runtime will start with a very important assumption. Everything compile. This is why if in your programming test, if there's a compilation error in your project, you're going to get some penalty on that, because if there's a compilation error, the computer cannot really execute the code you submitted faithfully. That's why you should get penalty. All right? So everything compiles is important to get to the runtime. And number 2, for the runtime is, so this is where we can simulate what's happening in the real world. We got objects, we got method call. Okay, I'll just put it down. So it's really the object creations plus some method call. That's typically what's happening at the runtime. And of course, if you try to execute your code at the runtime, you find that there's something wrong, not exactly what I expected. In that case, you should really use breakpoint and debugger to find out what's wrong. So number 3, I'll put it here, is really about breakpoint plus debugger to find out what's wrong. You got to be very clear about which phase is supposed to do what. Okay? And again, for this course, we focus mainly on these 2. But just for today, for the review completeness, I'm going to talk briefly about what this is really about. Very simplistic. Okay, let's talk about what's really about observing. We talk about different entity. What's an entity? Entity, just anything you can see around you. Okay? Let's say we got 2 persons over here. Entity number 1, entity number 2. Different entities. However, even though they're different entities, they are entities of the same kind. Agree? They kind of share something in common. Of course, they also got differences. So number 1 thing to say is, number 1, they are entities. How about this? I'll make it more explicit. They are different entities. Entities of the same kind. Let's say this person here is Jim, and this person here is Jonathan. Can I please just make sure there's no Jim and Jonathan in the class? I don't want to offend anybody. I can change the name easily. Okay, Jim and Jonathan are our victims today for the demonstration. Okay? Let's say we got Jim and Jonathan here. We're just observing what's really the same, what's really different between them. Let's see this. Entities over here, we got Jim and we got Jonathan. And of course, if you want to connect to Java right away, we got one object representing Jim. We got another object in the memory representing Jonathan. They are different parts of the memory, different objects. And the second part here about attributes. This will be common among all the entities of the same kind. For example, we might choose to characterize each entity by common attributes. Let's say we want to characterize one person by their weights and their heights. Also, we can characterize another entity of their weights and heights. So basically, both of them got weights and heights. But the specific values, or we say the instance specific value for their weight and height for each entity might be different. You see the difference here? Okay. So the common attribute here would be the weights and the height. Okay. And then, for example, let's say inquiry, let's say if you want to know about the get weight. Okay, let's say I want to know what's really the weight for Jim and what's the weight for Jonathan. Both of them has the weight attributes. However, the instance specific weight value will be different. That's the beauty about OOP. It's just simulating the reality. So here I'm going to say, so here you might say Jim dot get weight versus Jonathan dot get weight. Okay, so here. And I would like to talk about this a little bit more closely. I want you to focus over here. I want you to, sorry, that's the best I could do. Look at this line here and this line over here. Jim.get weights and Jonathan.get weights. Okay, just for now. Compare with these two lines. There are something that these two lines are the same, and there are something that this line are different. Can you tell me exactly what they are? Tell me what's really the same between these two lines. Yes. The method name, or we are making the same method called get weight. I agree. Let me write it down first, and then I'll have you say about what's really different. So here, you can see here, the get weight here and the get weight over here. So this is really the same method call. Okay, let me go back. Now, can you tell me what's really the difference between these two lines? Which should be quite obvious, yes? I like it, yes, I agree, because the object that we are trying to invoke the method on, which one would be Jim, the other one would be Jonathan. Do you guys remember how do we refer to the objects being invoked, the method? What's the name? Context objects. I love it. Thank you. Thank you. So the context object is really everything when you want to trace the OO code, which we'll do more exercise later. So what you really want to know is Jim here and Jonathan over here, right before the dot. So these are different context objects. I'll just say OBJ. Okay, different context object. Whenever you want to trace some piece of OO code, you should always be aware what the context object is for each method call. Calling the same method but on different objects might give you a different result, all right, of the runtime. All right, so, here we were still just talking about, how, so we can get a weight maybe from these two persons, or maybe this person can maybe grow higher, or this person can grow higher, etc., right? So there are different things we can manipulate the entities. But after all, up to now, we are still being a little bit informal, just about what we can observe. Ultimately, we want to create some templates, which I'm going to write here, the template. And in this case, it would be just person. So person is going to be the single place, single template, where we can instantiate as many entities as we like. Jim will be one. Jonathan will be the other. It could be Peter, it can be Alan, can be whoever, right? So that's really the idea we're going to keep doing. Fortunately, for your subsequent labs and the tests, programming tests I'm referring to, you will be told about what classes and methods you're supposed to create for your project. But just remember, if you're really a complete engineer for software, even observing to find out what classes, what attributes, and what methods you will need is also part of your job. But it's just not what this course will cover. Okay, I'm just mentioning that briefly. What I want you to really try as an exercise, which I'm going to put here, okay, exercise. Okay, I'm going to put it here. And I'm referring to this particular diagram. And I'm sorry about being a little bit unorganized on the notes, but you can see this one here, this diagram. Right? It's a different kinds of entity. We have a two-dimensional plane, x and y. We got two entities here, point number 1 and point number 2. For example, we might say this point over here, maybe 2, 3. And this point here, maybe -1, -2. Right? Two entities. And now, can you give yourself some examples about entities, attributes, what change you can make, what inquiries you can do, and also the template. Easy exercise. You can do that by yourself. Okay? Okay, before I get there, let me go back to the slides. Before that, any question about this process over here? Okay, let me highlight one more thing, if I may. So we already talked about this first phase. Once we get to the Java, you can see we can get one template versus another template. Each template can be instantiated to create objects for as many times as you like. That's something we'll do when we do the demo. Once you declare or define two different templates or two different classes, you can now try to execute at the runtime. I may want to create one person here, another person over here. I may create one point here and another point here, and now I can start manipulating them in the way corresponding to how I perceive the reality. Okay, one more annotation you can see here. What we're doing is this person here, this person objects, is really corresponding to the gym that we observe. And this person, Jonathan, over here, is really corresponding to the second person or second entity that we observed earlier. So OOP, why it is so useful is because it's really about corresponding to what you can observe in the reality, right? Translate whatever you can observe in the reality here into computer memory and manipulate them in a way that can give you the solution. All right? All right, guys, any question over here? It's a little bit like a crash course about what OO is really about, just about philosophy. Think a little bit deeper about this. It may take some time to really get what I'm trying to say here. It might take some time, but I think it really makes sense. Yes, question?
Sorry, can you explain
yes.
templates again?
Templates? You mean about, okay.
Again, like their use.
Okay, templates, sure. So how about this? Let's understand templates and classes together. It might be a little bit more easier. When I observe these two entities, let's say person 1 and person 2, they are different entities, but they are entities of the same kind. They are both persons. Template is really for you to characterize about some common attributes of all the entities of the same kind. So now, if in order for me to create a template that's going to be applicable for persons like Jim and Jonathan, one possibility could be the person template over here. So here I'm saying there is a template called person where each person entity should have their name, weights, and height. Everybody should have these three attributes. That's how we characterize them. However, for individual entities, for example, Jim, okay, let's say Jim and Jonathan. Even though both of them have the weights and heights, but their weights and height will be different over here. Also, they both have names, but their names are also different, right? So that's kind of the subtlety you want to watch out for. There are certain things entities share, and there are certain things entities do exhibit differences.
So can they be part of the same template if they have different weights, for example?
Yeah, of course.
Okay.
Yeah.
But if, say, one doesn't have a weight at all?
It's not possible. If I say I have an entity that's instantiated from person, it must have all the attributes that's already declared there. It's why it's called template. In some way, whenever you're trying to instantiate a template, you basically inherits, well, not inheritance, what I'm talking about. It kind of inherits all the attributes from that particular template. Make sense to you? Good, very good. All right, guys, any further clarification needed? All right, let me know. All right, let's now move on. All right, I think that this is another little bit more elaborate explanation of everything about object orientation in this optional tutorial video. If you want to watch it, feel free. Again, optional. All right, about OOP here. So this basically just summarizes about the attributes, behavior, like a methods, everything here, which I already explained. And you can also refer to some notes over here. You can also keep it handy. So this page here also summarizes about everything you're supposed to know about the basic ingredients of OOP. So we got templates versus instances or entities. So they correspond to classes and objects in Java, right? That one's easy. And we're going to talk about attributes, which will be the common characterization of different entities of the same kind. And also the methods, we know that there are three kinds of methods. We got constructor, accessor, or getters, and also mutators or setters. And as we do the coding demo later today, maybe Thursday mostly, then you will see. I'm going to review how you can define each one of them. And in Eclipse, they also got something called refactoring. Okay, you may have heard about the term before. I'll try to give you more example as I demo. But refactoring, whenever you hear about this word over here, it really means to make some change in your code. One simple change could be to rename an attributes, or it could be to rename a class. These are the more non-semantical changes, which means it does not change any meaning, just change the name of different, like a class or attributes in your projects. But the more complicated refactoring, one example would be how you can refactor methods into helper method, which is something I'm going to show to you tomorrow. Okay? Another one example here would be to helper method. All right, that's for tomorrow. All right, we talk about instance-specific attribute values, and we can create objects by using constructor, and also we can use a dot notation. So here the dot notation, I want to give you a little bit look ahead. What you might be very used to back in the first year might be something like this. You have some object number one, let's say it's not null, it's already created, let's assume that. You might say object one dot maybe M1. M1 here might return some value, or M1 might be a mutator, which does not return anything. Either way, right? You might think that's it. Dot, maybe as simple as that. Not really. Dot can be as complicated as it should be. Remember the single sentence I said earlier? I said you can expect more than one classes in your project. Because you got so many classes in your development project, how do you navigate between them if they are somehow interconnected? The way to do it is by using the dot notation. I will give you the more sophisticated example when we talk about the aggregation after the reading week. But now let me just sketch syntactically what you can expect. You might even have to use it in your lab number one onwards. Okay? So don't be too surprised if you have to write something like object number one, the M1, and then the M2. And the dot over here can continue for as many method call as needed. That's the beauty about OO. You basically, what I will show maybe a little bit later, every dot suggests some navigation to another class or the same class, depends. There's a path over there. But for now, you just have to be aware the dot can be multiple, doesn't need to be just one. Okay, that's the main point. All right, so we'll talk about the right context object basically, right? Just remember. But we'll see more demo as I proceed with the review. Let's go back to the slides. Okay, so okay, just one more exercise I would like to show to you. So I'm going to leave this page blank for you. You can also do some exercise here. So this is still the observe phase. Remember the first phase I said is beyond the scope of this course. I'm going to give this particular page to you. You can try to see if, let's say, you are given this particular problem to solve. You got problem number 1 and problem number 2. Based on these two informal description, how can you decide what classes, what attributes, and what methods you're going to create for your projects? In your labs and in your programming test, you don't really have to go over this stage. But if you want to exercise, I would suggest try this one here and try this one here. Okay? And then if you want to discuss your answer, which may not be the same as mine, we can talk. But again, doing this exercise here, it's only for your own good. It's beyond the scope of this course. Okay? I'll assign that to you. But for this one here, we can do a little bit, okay, just to make a better transition to the next topic. What I would do instead is to give you a table here, okay? I'm going to do this column only, just to summarize about templates and instances. Let's do that. I'm going to do this column here. So this column here corresponds to the Jim and Jonathan that we did earlier. We are already familiar with it. Let's now try to see how we can summarize our OO observation from this. And then for the points, and also this one here, I'm going to let you do it on this column exercise. All right? In case you forgot about what the exercise is about, you can always rewatch the recording. Okay? Let's now do that quickly. So we want to figure out for each individual example, what's really the template we are creating? In this case, only a single template. And also, what are the common attributes that we define in the templates to characterize all the entities? And what are the common behavior, usually just refer to methods that we can define for those entities? And what will be the instance-specific attribute values or methods, result that we can expect? All right, so let's see. So let's start with, we got a person here. Person is a template. All right? And what are the common attributes here? We got weights and we got height, right? You can think about weight and height informally over here, but it's better to also think about their types over here. Right? What should be the types for weight and height? Should it be integer, string, or something else? Yes? Double? Why double rather than integer, for example? It's more specific, or because it has a fractional part. You might say for weights, you might have 70.7, for example, right? So that's why you need a double. Good? Yeah, so these are the kind of like a programming decision you have to make when you develop your projects, right? Just remember. All right, you can say double here, and also double here, right? That's why I said types is important. That means every entity instantiated from this particular template has a weight, has a height. But the specific value for weight and height might be different. That's okay. But every one of them must have weight and height. No compromise. Right? What about common behavior? So whenever you talk about behavior, like action, what kind of action can you perform upon entities? So these are normally turned into methods. Right? So for example, you might have, let's say, get. Let me just write a little bit more properly. You may have get weight. All right, in that case, maybe it's going to return the double. That's one example here. Or you might have, let's say, gain weight. Let's say gain weights by a certain amount. I would say amount, let's say D, certain amount. Right, here we got void. Right, so very quickly, I'll talk a little bit more about how you can design the parameters for your methods, maybe a little bit later in the review. But let's just talk about these two examples. You got get weights, you got gain weights. One returns a double, The other one does not return anything, right? We do have a special names for this kind of method, right? So we know that this one here is called accessor because it returns something. And this one over here is called mutator. It does not return anything, but it is expected to modify something on the context objects. For example, if I say Jim dot gain weight by 2 kilograms, for example. In that way, you can see I'm trying to call a method that's a mutator. It's void, does not return anything. So what I'm expecting to really happen after this method call is the context object Jim, it should be modified somehow for its attribute value. I'll write it down. The context object is expected to be modified for its attributes values. On the other hand, if you're calling an accessor method over here, you're not supposed to modify anything. I'm saying you're not supposed to because once you go dive into the workplace, there are so many people violating this rule, meaning that when you're calling an accessor, they want to have some side effects of modifying the object at the same time. But it's just not a good practice. I'm just talking about good practice. The good practice should be as follows. Whenever you got accessor that returns something, you should not modify the attributes for the context objects. You should not. That's something you will see also in the lab solution. On the other hand, whenever you're declaring some mutator, that means your intention is whenever some user want to call the mutator on some context objects, they really want to modify the context objects. So these are the two distinctions, right? Quickly. All right, so instance specific value here. So we can have, let's say, double. I'll just give you maybe get BMI. Oh, let's say we got another method called get, how about this? Let me write a little bit more properly. Again, let's say we got Jim dot get BMI, which we're going to implement together once I do the code demo, versus let's say John dot get BMI. Right, we are running into the similar scenario which I kind of asked you guys about, right? Let me just do that quickly, just here. The same method call, but we don't necessarily, we might just get back different BMI values because we're talking about Jim versus John, different context object. Similarly, over here, if you got Jim dot, let's say, gained weights by 2 kilograms versus Jonathan or John dot gain weights and then by 2 kilograms over here, again, you can see we are calling the same method even with the same input values over here. But are they going to modify objects the same way? Oh, are they going to have the same consequence? Not necessarily. Because here you're gaining the weights for 2 kilograms for Jim versus to a different person, right? So the consequence could be different. That's the kind of like conceptual planning you should really have whenever you want to plan to create some templates yourself. Just think about what might be the use cases for the template. All right, I'm going to assign this part over here as an exercise for you that will correspond to this example. All right, it's up to you. If you want to discuss the answer, let me know. And I'll just put exercise over here. Good. Okay, for all thinking, so here we have gone through everything. Okay, you can go over them. Well, actually, this is more or less like a solution to the exercise, but you can look at them maybe later once you have done the exercise. All right, so up to here, everything you can go through. And this is just like a summary about once you have made up your mind about templates, attributes, this is like a Java syntax, right? For today, or at least for the review, let's not worry too much about the private just yet, okay? So just focus on the actual variable values and also visualization for later. All right, let me talk about something also very important, which is about data types. All right, let me just go over maybe the first slide, and then I'm going to write down some important information for you on the iPad. So a data type denotes a set of related runtime values. That's a definition for type. I'm going to clarify that in a moment. Okay? Let's just go over some bullet points. What are the different types in Java? Anybody? If I want you to give me the categories of types. Primitive and reference? Awesome answer. That's perfect. You got primitive types, in which case you got integer, you got numerical type, basically. Integer, floating point, character, Boolean. And notice that I did not have string type over here. Is that a mistake? Okay, so in case you're wondering about it, notice that string, we even though use it so often, maybe already back in your first year, string does not belong to the primitive type category. String is a reference type. There is indeed a class called string somewhere in the API library. All right? So the way to really remember this, if you want to, is to remember all the exhaustive list about primitive type, which will be these ones. Anything that's outside this list will be reference type, mostly. Some example here. So we got reference type, complex with attributes and methods. Okay? And we got string, right? Already the first example here. And also person or points and whatever, or even scanners. By the way, scanner is one of the Java API library classes. Just put it here for example. And let's clarify over here. So what I want to do is, okay, so I'm going to write down 2 rules for you. Number 1, in Java, each variable must be, you have no choice, declared with a type. And give you 2 examples. You might say integer I, or you might say person P. Okay? So if you simply try to declare I without supplying its type, Eclipse is going to give you an error. And for those of you who I believe for engineering students, when you took maybe 10, 11, you learn about MATLAB. I'm not too sure, correct me if I'm wrong. You don't really need a type for variables, do you? Maybe not, right? Okay. And for those of you who took 10, 15, Python or JavaScript, you don't need a type either for variables. So there are certain programming languages which we call dynamically typed languages. They don't require variables to be declared with a type. Convenience at the compile time, but very disastrous in the runtime, in my opinion, because you can easily try to assign string to an integer that has no complaint from the compiler at the compile time, but it might run into issue at the runtime when you execute the code. But in Java, it's not going to happen. Okay? In Java, let's say, if you declare I to be an integer, and now you try to assign a string into I, you don't even get a chance to execute that line of code because the compiler is going to give you an error. That's really the precautionary measure the compiler can do for you. Okay, so I'll just, okay, that's a rule number 1. You must have a type. And number 2, which tells you what's going to happen at the runtime. A declared type denotes the set of values that is allowed to be stored in that variable. So you should really try to look at these two rules side by side. They are connected with each other. Okay, for example, I got primitive type attribute integer I. Once I declare that, I can only declare once, by the way. Once you commit to it, you got to commit it forever. So now I can say I is initialized to be 23. 23 is, well, here, integer here will denote the set of integers. So any integer can be stored into I at the runtime. So now I can say I is initialized to be 23, but can I say I is reassigned to be 46.7? No, unless you do a cast, but that's okay. Let's not worry about it. Okay? Nope, you cannot. So this is really what the rule number 2 is telling you over here. Okay, one more. What about this one here? This is more interesting when you talk about reference type attributes. Okay, so now, can anybody tell me this? I'll put it here. All right. I declare P over here to be of type person. All right. And now, if I say I want to do a variable assignment, P is assigned to something. What can the question mark be? I can think of at least 3 possibilities. Maybe you can think of 2, I guess. I'll start with you. Give me one. New keyword, yes, creating a new object and let P store that particular address of the object. Very good. Let me write it down. Awesome. So for question mark over here, option number 1, right? It could be P is assigned to new, and make sure you say person over here. You're creating a new person object and store its reference or address into P. All right, new person and whatever you put over here. Oh, by the way, ... is not what you can write in Eclipse. I'm just saying some details to be filled in. That's what I meant. What about number 2? What's option number 2? And you.
It could be an already existing object.
Of type? Yes, it can be another already existing variable, which is also of type person. Yes, indeed. For example, here I got maybe person P. I got another, let's say, person P2. All right? So somewhere in my code, I can say P is assigned to P2. Java compiler is going to look up for you. P declared to be person, P2 declared to be person as well. So you can assign one to another. That's option number 2. Option number 3. A little bit similar to option number 2. But that one there, don't worry, I'm not gonna trouble you. That one's something I will talk a lot about when I go to inheritance. But I'll just write it down. The reason that I'm mentioning this over here is because later on when you review for your exam, let's say later, when you see the 3, it will have already make sense. Okay? Number 3 would be, you can say P is assigned to maybe another variable that's called P3. But here, the P3 does not need to be declared of type person. It can be declared of any type that is so-called a subclass of person. And if you don't know what a subclass is, don't worry, we're going to talk about it for a month after reading week. Instantiated from a subclass of person. For example, there may be a subclass of person called professor. There might be a subclass of person called students. There might be one called, I don't know, employer. Something like that. But for option number 3, don't panic. That's something we'll talk about properly later in the course. All right, so that's about the types you should really know about. And then, let me just say one more thing. How about this? Because I also mentioned this in the morning session. I just want to be consistent. Make sure you don't miss anything. Another thing I want to clarify is what's really the difference between you declare some primitive type attributes versus reference type attributes. Okay? How you should really understand the difference between them. Let's say you got integer I versus person P. All right, over here, so this is primitive type. And this one over here is reference type. Okay, let's make sure we know that difference first. And according to our rules that I talked about earlier, here we say for I here, at the runtime, I can store some, or let's say any, integer. So the way to visualize it is very straightforward. Let's say I got I over here. It's a box. I may initialize the value to be 23, but I can easily replace it to be another value, let's say 46 later. Right? As long as it's an integer. The same box, throughout its lifetime, can only store integer, the declared type. And the second one over here, you would have already seen some visualization in Lab 0 Part 1, but let me just repeat that briefly because it's so important. If you look at this declaration over here, at the runtime, P can store the, you can say either reference or address of some person objects. How do we visualize it? There are two ways to do it. I'll mention both. Approach number one. P itself is also like a box, just like the integer box. Small box. That means it cannot store much. And then, let's say you might be storing some address over here, 06123. So that's an address. And 06123 really corresponds to the computer memory somewhere. Let's say that's a computer memory. Somewhere in the memory, the starting address is 06123. Starting from there, we store an object of type person. So this is kind of indirect. So P does not store the entire object, which contains maybe the weight and height of a person. It does not store all the information there. The only thing P stores is the address. It's indirect. Okay? That's one way to visualize it. I would say that's important. That really tells you what's really happening there in the hardware. Right? But later on, when we get to the need for tracing complicated code in expressing Java, this is not the way to go. You'll be too slow. You'll be a little bit too troublesome to draw. So the way I would recommend goes like this, which I'm going to do throughout the course. The second way to trace this would be something like this. P is a reference variable. I know that somewhere in the memory, I have an object of type person. Given that the type is of type person, given that the type corresponds to the template person, I know that it must have weights and heights for every entity, including the current one. Right? The weights may be something, and the height may be something, right? Now, how do we connect these two together? So the P over here does not store the entire objects. P is not that big. It's only a small box. So what you should really draw instead is to say P is pointing to this particular box. This is a very important point to understand over here. we don't really put the P right beside the box. That's not conceptually right. We're saying that P itself is an address, which refers to this object over here. When we actually want to trace the code related to aliasing, we need this so badly. So please make sure you understand this. Okay? Are we okay about the two attribute types over here and how we visualize it? Are we good? Yes? Sorry, say it again. What does it store in the hardware? Somewhere in the memory, or maybe in the register. That's not something we will get too much into. I think your 2021 computer organization professor might be able to answer the question better than I do. Yeah. Any other question? Alrighty. Okay. Let me go back to the slides, and I think I got, okay, over here. So second part of data type is about default value. Basically, every time you declare some variable, for example, integer, if you don't really initialize it, it's going to give you some value by default. And I'm pretty sure you've seen that already before. So for numerical type, it's simply 0, right? And for Boolean, it's false. And that's it, okay? And for the reference type, here's the interesting. For the reference type, it doesn't matter what class it really corresponds to. The default value for any objects always just null, which means you have no valid address somewhere in the memory for you to refer to the objects, just null. So for primitive variable, you can use it when it's uninitialized. But if you try to really call an uninitialized reference variable, you're going to get something called null pointer exception. Have you seen that null pointer exception maybe back in the first year, maybe? If you haven't, don't worry. I'm pretty sure you'll see that a lot in your labs in the programming test. I'm pretty sure. It's a part of the learning. Even for the very experienced programmers who work in the industry for many years, they still run into this kind of issue. It's almost unavoidable. But you gotta just learn how to program in a disciplined way to really minimize it. Quick review about what null pointer exception is, quickly, and then we are almost get to the point we can take a break. Almost getting there. Maybe two more things. So let's talk about null pointer exception. Okay, let's understand the principle first. Number one, it can happen normally when in a method call. And a method call has the structure like this. You have the context object, let's say obj, and you say dot, and maybe you have some method m over here with some input value. This will be the simplest method call you can have. How can you have null pointer exception? Null pointer exception means the left-hand side, the context object of the dot, happen to be null. That means there is no valid object over there in the memory for you to invoke this method upon. One example. If I say Jim dot, let's say get BMI. This is a method call. There would be a null pointer exception if Jim variable does not store the address of some valid objects in the memory. Okay? Null pointer exception if Jim equals null. That's something you can also check either in the JUnit test or in the console application or in your code. Okay, I'll talk a little bit more about comparison a little bit later. Okay, so we talk about method call and also the context objects is null. All right, something slightly more complicated, but it's still conceivable. if I have some context object to start with, I say co.m1 dot m2 dot m3. Let's say this. Let's say it compiles. When I run this on Eclipse, somehow it gives me a null pointer exception. Now, your job as a programmer is to debug, or at least to try to understand what's happening over here. So where do you think the null pointer exception may have occurred? How many possibilities are there? How many? How about there's at least one possibility which you can see. Possibility number one, this might be null. Agree? How about this? This may be null. Is there another possibility to say CO is not null, but we still get a null pointer exception? Is it possible? Anybody? Yeah. Not M1. M1 is a method. M1 cannot be null. It's a method. But I can see where you're heading.
Yeah, the value returned by M1.
Or the value returned by co.m1. That's more complete.
CO.M1 or CO.M1.m.
Mm-hmm. Okay. Possibility number two is co.m1 itself returns a null. Another possibility will be co.m1.m2. That's the third possibility. co.m1.m2. Maybe it returns a null. All right? So this is a more conceptual sketch, but it makes sense, right? So this might be something that might be useful to you. For you, let's say later on doing the different labs, if you really run into null pointer exception, my point is, it's not necessarily always the very leftmost context object that's null. Not necessarily. If you got a long chain of method call, it could be anywhere. So if you want to debug, you don't want to miss any possibility. That's my point. All right. Okay, so that's good. Okay, so now I want to write something here. It's a assigned reading. I think from slide number 16 all the way to slide 47 can be self-study. But as I go over the in-class demo on the Eclipse, hopefully I can start a little bit today. That's something you can definitely start. I'm going to cover everything from there. Okay, so what I will do is I'm going to say here, slide 16 to 47, assigned reading. All right. So please do that. If you can do it by Thursday, that'll be awesome. If you do it by next Tuesday, equally good. All right. Let me see what I got. One here, two here. Okay, how about this? I'm going slightly slower than the morning session here, but we still got about 11 minutes. How about we do this? Why don't we try the attendance taking right now, which we said we're going to experiment. And then let's say today without a break, if that's okay. And then I'm going to use the remaining 10 minutes to go over two more things on the iPad. And then next on the coming Thursday, we're going to start you fresh with the Eclipse demo. That's what I will do. Okay? So can you please have your iClicker ready on your mobile? Let's give it a try. All right, so there are two more things I would like to go over before we get to the code demo on Thursday, very quickly. And I'm going to use my iPad for these two. Number one is about the difference between parameters and arguments. It's very important to also clarify these two ideas, right? Some programmers just like to talk about arguments always. It's not that precise. I think that these two names really denote different context in your code. I'll get right to the point and give you some example. Okay? Whenever we talk about parameters, we are really talking about the point where we are trying to define your method in the template. For example, you can see we are defining this particular method here, get distance from. That one there has one parameter called other. In another method called move, we got another two parameters with the names, right? Parameters here and also parameter over here. So all these three are called parameters. One here, two here, and three here. They are called parameters. As easy as that. Whenever you're declaring the header or API of your method, the names you use as the input is called parameters. What about arguments? Argument is when you try to call or invoke the method. You have to pass some input value that's compatible with the type of the parameter. So for example here, if you want to invoke this method here, you must pass something that's compatible with a point. Okay? If you want to call this method here, you must pass two things. The first thing must be a character, and the second thing must be a double. Those things you passed in individual method invocation is called arguments. Let's see. So let's say we got two objects over here, P1 and P2. And then we are trying to call get distance from and also get distance from. So we are now really referring to this method here. We're calling the same method twice. Over here, right? So you can see the argument that we are passing P2 and P1, they must be compatible with the other that's declared to be of type point. So these two are called arguments. That's when you try to use the method as opposed to define that. It is so important for you to really understand the different contexts over here. Right? I'm going to make it here. Okay, you can see here, we got parameter and we got arguments. A single parameter may be satisfied by multiple arguments. Similarly, let's say we try to call this method move over here. What arguments can we pass? The first argument must be compatible with the first parameter, which is character. And the second argument here must be compatible with the type of the second parameter, which is double. Okay, is that clear? How about the terminology? Okay, good. I hope that's clear. Any question about this? That was easy, so I think we can do it today. One more. I want to talk briefly about, I only got 3 minutes. I'll see what I can do. Okay? I want to talk about the scope of the variables in class. It's really about what variables can you really refer to either for access or for modification in different places in your Java class, right? Let's talk about it. I got 3 different rules over here. Please take a read. They are rather straightforward, but let me just illustrate them right now. So I got one class over here. I got 2 attributes. So these are class level variables. So these are the class level variables. Class level. And for class level variables, you can refer to them in any of the methods without any trouble. For example, I might say here, m, which is a local variable for m1, is assigned to I. I'm accessing it, right? I here, I can access that in this method here. Or I can modify that in another method. I can say I maybe is assigned to n over here. Right, you can see over here, I is being modified. Both are fine. Whatever illustration I'm doing here, I will encourage you to reproduce this code in Eclipse and try more and let the compiler teach you about how you can have valid versus invalid usages. That's what I will encourage you to do. Okay, what about another rule? Let's say you got your parameters P1 and also parameter P2. So these are called method level. They're only available to the method that's being declared. So over here, if I say m is assigned to P1, that's okay. Because M and P1, they're both within this M1 method. That's okay. However, if I try, let's say N is assigned to P1, is this okay? No. Because you can see that over here, P1 is declared over here is not in the same scope of M2. The scope of M2 is only within this particular method. You cannot refer to a variable P1 that's outside the scope over here. All right, that's another rule. Okay, one more, and then we are done. We have also local variable over here. You can see M here. Yeah, that's what we call the local variable to the method. And it has the same rule as the parameters. So you can only refer to this local variable in the declare method. So now you can refer to maybe, I don't know, maybe you can say another local variable, let's say M2 is assigned to M. And now, just give me 1 minute and then I can get it done. So here M, you can refer to it in the same method. On the other hand, now if you say N is assigned to M, obviously that's a mistake because you're really referring to the M here that's belong to another method. So you cannot do it. That'll be wrong. All right, so this is a quick example here. Give a try on different combinations there, and then we'll start with the code demo from Thursday. See you later. Meet me outside, please. Yeah.